Hey guys, welcome to yet another USACO problem. It's almost Christmas, and today we're going to be doing the 2017 January contest silver problem hoof paper scissors. Now in this problem, Bessie and Farmer John are going to be playing N games of hoof paper scissors, very similar to rock paper scissors. And for the first X games, Bessie is going to play a certain gesture, but she is going to switch for the rest of the N minus X games. And our job is to find the maximum number of games that Bessie can win by doing this. To get a better understanding of this problem, let's take a look at the sample input. In the sample input, we're given that we're going to be playing 5 games of hoof, paper, scissors. And Farmer John is going to be playing paper, paper, hoof, paper, and scissors. In this case, the optimal combination for Bessie is going to be playing scissors first to counter paper, and then play scissors, and play scissors, and play scissors for the first four turns. So X is going to be equal to 4 this time. And then for the last turn, she's going to switch, and she's going to play hoof to win against scissors. So if we count up how many games Bessie has won in this case, we can see Bessie has won the first one, Bessie has won the second one, lost the third one, won the fourth one, and won the fifth one, giving us a total of 4 wins. So the first observation that we're going to make is that it really doesn't matter what gesture beats what gesture. Because in this case, Bessie kept on playing scissors for the first 4 rounds and beat all of Farmer John's papers. So no matter what gesture Bessie does, it can only beat one type of gesture that Farmer John does. So Bessie could either beat all the papers of Farmer John, beat all the hoofs, or beat all the scissors if Bessie is not going to switch. So in this case, if we wanted to switch right here, then this would be a group and this would be a group. And for the first group, Bessie would obviously want to beat all the papers because that would give her 3 wins. And she wouldn't want to beat all the hoofs because that will only give her 1 win. So in each group, Bessie wants to get the most wins. And that means finding what Farmer John's gonna do the most. So now all we need to do is get all the possible ways of splitting the array into 2 groups. And let's say if we split it here, we're gonna get the most played gesture that Farmer John does for each of the groups. So for this one it would be P, and for this one it's a tie. And then after that, we're just gonna count how many times Farmer John plays this gesture. So for P, he plays it 2 times. And that will mean that Bessie is gonna win 2 times in this group. So it will be 2. And the most played gesture is a tie because he played every single gesture once. And so the number is gonna be 1. And Bessie is gonna win once in this group. And if you add up these, you'll get 3. That would be the final amount that Bessie wins if she switches gestures right here. Let's take a look at the code for this problem. So we're first going to read in the number of rounds we're going to play. And we're going to make a vector of characters called Farmer John that represents what Farmer John is going to do. And we're going to have these 3 variables here. We're going to have H2, P2, and S2. So this basically means how many hoofs has Farmer John played on the right group. And P stands for paper. So how many paper Farmer John played in the right group. And then also how many scissors. So we're going to cycle n times. And for each of the n, we're just going to read in the current gesture that Farmer John is doing. Then we're going to check if the current gesture is H. in that case, we're going to increment h2. We're assuming everything is on the right side currently, and the left side has nothing. So if it's h, we're going to increment h. If it's p, we're going to increment p. If it's s, we're going to increment s. Now we're going to actually start simulating or trying all the possibilities that the two groups can be. So we're going to have h1, p1, and s1 as separate variables for the left side, and we're also going to have a result. Now, we're just going to cycle n times, and for each of the n, we're again going to check if it's h or p or s. So in this case, if it's h, we're going to increment the left counter and decrement the right counter. So we're going to add 1 to h1, but minus 1 for h2. We're going to do the same for paper and for scissors. Now that we have both of the groups, all we need to do is calculate how many times Bessie is going to win on the left side and how many times Bessie is going to win on the right side. So for the left side, it's just going to be maximum of h1, p1, and s1. Whichever is the biggest, Bessie will take. And for the right side, it's going to be the exact same thing, but with h2, p2, and s2. And then we're just going to make the result the max of the current result or the left plus the right. And then at last, we're just going to print out the result. And that should be the end of the program. This problem technically uses the algorithm prefix sums, but if we make one observation, we can make this problem very simple to solve, and it will almost feel like it requires no algorithms. Hope you enjoyed the video, and I'll see you in the next USACO problem.